Hello viewers and my dear students. Welcome to session 3 on isometric projection demo of my main problems, what I've done in my notes, what I'm discussed in different sessions under isometric projection. And here I'm showing this demo using solid edge. We have already covered 2 sessions on this. More or less the problem is completed. I'm giving you an idea about orthographic projection also based on this. See here, we are actually like this. See here, this is the problem what I told you. Okay, I'll just give you some more information. Let us say this is okay. Let us say this is C naught naught. Okay. Now, as you know, C naught naught is the center of the bottom surface of the cube. C naught is the center of top surface of the cube. C1 is the center of the sphere. Correct, no? Center of the sphere. And also you know very well, this, you please understand, okay, this let us say I'll call R. Now I'll explain in detail what exactly is happening here now. Though it is simple, you'll know lot of concepts here. Now, as you know here, you have placed one sphere over one cube. Okay. Cube has been raised about this corner. The base of the cube has been raised up. Why I have raised is I want to see the top surface. That is the basic concept of any isometric projection. Okay. Now that is why I darken the top surface, I darken the left surface, I darken the right surface. When I raise this about this corner, when the base is raised, all these edges will reduce by 0.816 times the original length. Original length was 50. Now I have reduced by 50 into 0.816. This will be actually, if you see it as 40.8, that is 50 into 0.816. That the reduction will be 0.816 times the original length, which you can prove it. There is a proof and all that. And this you should know that there is a proof and all that. Since it is beyond the scope of this subject, I am not going for the proof of that. Right now you should know ISO 50 means it is 50 into 0.816 times the original length. Why it will reduce? Because when it is tilted over a corner, when the base surface is raised, in order to see the top surface, all these distances, okay, when it is 30 degrees, no, when it is raised for front view inclination of 30 degree, all these edges will be inclined to VP, and when it is inclined to VP for 30 degrees front view inclination, you can prove that the distances will reduce by 0.816 times the original length. That is why here afterwards the scaling factor is 0.816, which you remember always. Okay. Now you see here, C naught naught. First you draw this cube of sides 50. Actual sides only you take 50 as I've done, and then take a scale factor, multiply by 0.816. You get isometric projection of a cube. Then C naught naught, C naught C1. That is the combined axis of the two solids kept one above the other. Correct, no? This C naught naught, C naught C1, this combined axis is parallel to one of these vertical edges. Can you follow? When it is parallel, this has to undergo 0.816 reduction in its original length. That is why what I have done is C naught is the top surface, center. C naught to C1, okay, I have taken ISO 25. You see here, ISO 25. C0 to C1 is ISO 25 means 25 into 0.816 actually. Okay, if you use the calculator, you take 25 into 0.816, locate C1. Once you locate C1, C1 as center, through 25 you draw a circle, otherwise draw a circle and move with respect to the center and place it here. Did you follow? In this way, you are able to complete the two solids kept one above the other. Always remember, the spheres won't reduce in the diameter or radius in isometric. Whatever may be, because there is no corner or edge, whatever you do in the front view, it will always look like the same diameter. Okay, if it is sphere of 50, it looks like circle of 50. If it is sphere of 100, it looks like a circle of diameter 100. If it is a sphere of diameter 200, it will be a circle of diameter 200. Okay, in that way, this you should know. But the axis will reduce. That is why C0 to C1 you take ISO 25, C1 as center, through 25 you have drawn an arc, or draw this separately and put it here. Okay, and clearly call R equal to true 25. This is 5 diameter 50. This you have done it. This is the isometric projection. Immediately you call this as isometric projection. Isometric projection you call it, and this you call this as isometric projection. You are more or less over. Okay, this is the thing. Now I have told you, see carefully, I have told you the concept of orthographic projection also, which we'll be doing in the next chapter. Okay, but I have told you already in the sessions and all that isometric projection is a separate question, orthographic projection is a separate question. Any one of them you can do. In that way, if you know the concepts, you can beautifully do both the problems if you want. And in fact, you are doing only one of those problems in the exam in some of the universities. Okay, there will be a choice between this and that. Sometimes these two are clubbed also in some of the universities. But learning isometric projection and orthographic projection very crucial for engineers. Okay, now you see here. Now you see this leader. I can give this direction. I can give this direction of vision. Okay. Okay, I can give this direction of vision for front view. I can give this direction of one direction of vision. If I give this, you have to write front view, that is in this direction, top view. Since left view is predominantly seen, left view only you have to draw on right profile plane. I can give some in the next chapter. No, they'll give the same problem. They'll, instead of giving front view direction this way they'll give. In that case, when you look from this direction, front view, top view, since right view is predominantly seen, right view on left profile plane you have to draw. Okay, now you see here, they'll give like this. Okay, front view. Okay, please observe, this is the front view direction. Okay, I've told you front view direction can be either here or here. If it is front view this way, you have to draw what? Front view, top view, left view on right profile plane. If the front view is here, you have to draw front view, top view and right view on left profile plane. This you remember. Now you see here what I'll do. See carefully. I'll draw one XY line. I'm concentrating on orthographic projection now. Now when you are looking from here, what you can draw, you can see this square, no? Front view. Front view will be this square. Okay. That is okay, I have drawn front view. This should be 50 square. Actually, it is 50 square. Now I'll dimension this also. You see here, 50 you draw. 50, and this also 50 you draw. Okay, this is the front view of this, and immediately you write the corresponding top view. First, let me darken this, because anyway these things have to be darkened. Okay, front view is this, and I'll come to the top. Okay, you leave any distance here. Okay, from here you take 50. Okay, now we are concentrated on this portion, you remove it off. Okay, now you see here, this is the top view of the cube. Okay, I am concentrated front view and the top view. Okay, front view is this, top view is also a square. That means that that is, if you draw this xy line, okay, xy line here, xy line here, you have VP above, you have HP above, front to top view of the cube is completed. Always start from the bottom solid, always, for completing. Then you have the this sphere. Sphere is also of diameter 50. That means first, okay, now what I'll do now, I'll just move it a bit. Okay. Anyway, the distance is known. Okay. Now what I'll do, I'll draw. This is 25. I'll go. Okay, from here I take this, I'll draw a diameter 50 circle. Okay, and escape. Okay, this will be the front of this. Okay. Okay, then as you know, your top view will also be a circle for this. What you do, again, go here, 0.13, make light. From here you take a projector. Okay, now what you do, again a top view of this will be a circle with this center, no? Okay, you draw this one. And immediately you darken this to 0.5. Now as you know here, this diameter, this length anyway is 50 only. Now as you know here, this will be the front view, this will be the top view. This will be the orthographic projection. This is our isometric projection. Isometric projection, orthographic projection, and this is C1, this is C0, this is C0 not. In that way, you are learning both. Thank you very much for watching. Thank you.